This is a podcast on how to write single replacement reactions. So you'll need your blue sheet and single replacements. They are the third rule on there, single replacement. It's where you have a compound and a single thing, and the single thing possibly boots out one of the other elements in the compound, and you have a new compound and a new single thing. It's kind of like a single switcheroo. And if the single item is a metal replaces a metal, and metals are written first. If the single thing is a non-metal, it replaces a non-metal, and non-metals are written second. So this chart is broken into two parts. Here's the dividing line. These are the non-metals, so there's only 1, 2, 3, 4 non-metals that you could possibly be looking at. But if you have a metal if the single item is a metal, you have all of these metals here. And you won't have all of them, but those are the options. And so at the top of the chart is the one that's the most reactive, and in class I talked about it being the most attractive. So if lithium is the single item, it will definitely boot out the thing that is in the compound because lithium is more attractive or reactive, and that other element really wants to be with it. But way down here at the bottom is the least reactive or unreactive, and they are the least attractive according to chemistry, but not to our visual eye-ness. So if gold were the single thing, gold could not kick out another metal because it's not attractive enough or it is not reactive enough. And this whole chart is a continuum. It goes from there and then it continues down, but there's kind of rules for each little grouping. So let's begin. Look at your worksheet number 3, and let's start with Ca. This is number 1 on there, Cl2 plus Sr. So you identify the single thing and you ask yourself, is it a metal or a non-metal? If you're totally lost, you could identify it either here or there. It's easier to eliminate it. It's not over there, so it must be a metal. So Sr is a metal. A metal would replace a metal, and Sr needs to be higher on this chart here to boot out Ca. In other words, Sr needs to be more attractive than Ca, and Cl would rather bond with Sr. So let's find it. Sr is right there, and it is 1 notch higher than Ca, so it will kick it out. I like to write the one kicked out way over here, so it's lonely and all by itself. And then you reconnect the new ones that bond together, which is Sr. Since Sr is the metal, it has to be written first. So Sr and Cl, you got to look at the charges. Sr is a 2 plus, Cl is a 1 minus, so you need 2 Cls over here. So it's SrCl2, and then you have to balance the whole thing. 1 Ca, 1 Ca, 2 Cls, 2 Cls, 1 Sr, 1 Sr, it's balanced. Ching! Let us try number 2 on there, and number 2 is sodium fluoride plus chlorine gas. So your single item here is a diatomic, so it must be from over here in the non-metal, so there's chlorine. So chlorine could only kick out one of those elements, and which element is given in this equation? Well, it's F. So you have to look and see if Cl is above F or higher than F. Cl is not above F, so that reaction doesn't take place. What it really means in chemistry terms is that F is so reactive that it could not be kicked out by Cl. Or in the funny terms, F is far more attractive than Cl, and Na in no way is ever going to let F go. So what you do in this case is you just write an X over the arrow and you say NR for no reaction, and if I asked you the reason, you'd say because F is up higher on that chart than Cl. Let's try number 3. Number 3 is aluminum plus Fe2O3, Fe2O3. Now notice the single thing can be written on this side of the arrow or that side of the arrow. I sometimes just switch it up to see if I can catch your brain and see if your brain doesn't get it. So you look at the single thing's aluminum. That's a metal. So a metal will only replace a metal, and the metal over here is Fe. And we have to find if aluminum is above Fe. There's Fe. Now where's aluminum? There is aluminum. Aluminum is higher than Fe, so it can kick it out. So Fe gets booted out all by itself, maybe some tears falling. And then Al and O connect, but we have to look at the charges. Al is a 3 plus, O is a 2 minus. So that 3 actually goes there, and the 2 goes there. I'm not writing above because I didn't leave enough space for myself to do that. And then you have to balance the whole thing. So I have 1 AL, 2 ALs. Let's try putting a 2 there and see if that works. Now I have, I should really look at the O's. Well, I have 3 O's and 3 O's. I have two FEs and 1 FE. I think I just need a 2 there. And then I think we're balanced. Let's try number 5 on that. Sheet number 5 is HCl, which is an acid, plus CD. Now, almost anything you drop in an acid is going to react with it, but sometimes it doesn't. So let's look at our single thing. Our single thing is cadmium. It is not over here in the nonmetal, so it's got to be over here. There's CD. And we don't have a metal over here in this one, but what acts like a metal or more like a cation is H. So C is CD above H. I found CD, there's H. CD is above H, so CD can kick out H. And then when H is written all by itself, it's a diatomic. You have to remember H, Nov, Cla, you just have to flat out memorize those or look at the periodic table and have it clue you into that. Those are always written with subscripts of 2. Now we have to put CD and Cl together. CD, that's a beautiful CD, and Cl, we have to look at the charges. That's a 2 plus. That's a 1 minus, so I need a 2 there. And we can check to see if it's balanced. 1 H, 2 H's, not balanced. What if I put a 2 in front here? 2 H's, 2 Cl's. So I had 2 H's, 2 Cl's, 1 CD, 1 CD. It's balanced. For our last one, let's try number 7. Number 7 is a little bit different. It may catch you off guard. Sometimes I put this one on a test to see if you're paying attention. So calcium plus water. Now, when I get stumped, and this one's one you're going to get stumped on, I look and see what I have, and sometimes if I have water, I write it as HOH because it makes a little bit more sense, because HOH is really an ionic compound composed of H, which is the positive part, and OH, which is the minus part. Now we look at our single thing. Our single thing is Ca. It's not in the nonmetal, so it's going to be over here. There's Ca. And the item Ca could kick out would be H. It's not a metal, but it's acting like a metal because it's a cation. So is Ca higher than H? Ca, there's H. Yes, Ca can kick out H. So again, we write our H2 over here because it's one of those that's diatomic. And then our Ca and the OH combine. Because that Ca got booted out, we're left with OH. I'm going to have to squeeze it in here. I'm going to put parentheses around it because Ca is a 2 plus, OH is a 1 minus, so I need 2 of those. How about I write a tiny plus sign in there? Let's see if we can erase the charges because you're not allowed to leave those in the final answer. And we got to see if it's balanced. It does not look balanced to me. 1 Ca, 1 Ca, 1, 2, 3, 4 H's. I can make 4 H's by doing that. And now I have 4 H's, and 2 times 1 O is 2 O's, and I got 2 O's, and it's balanced. So again, with single replacement, you look at your single item. On this chart, it has to be higher than the item in the bond for it to kick out. And the one that gets kicked out, if it's a diatomic, you have to write it with 2. Otherwise, it's just written with a 1 that you don't write. Good luck with single replacements. I'll see you next time.